Welcome to the deep dive. Today, we're tackling something you might think is, well, pretty straightforward: how children learn to count.
Yeah, seems simple on the surface.
But trust me, beneath this seemingly simple skill lies a really interesting debate between researchers like R. Gelman and R. Siegler, and we're going to explore their different ideas with the help of Roger Salyu's analysis.
What's fascinating here, and what we'll be digging into for you, is the fundamental question of what drives a child's ability to count. Is it a gradual understanding of core number principles that sort of clicks into place?
Or is it something else?
Or is it more about the hands-on experience? Counting things over and over. This isn't just about basic math. It touches on how we learn and develop really any intellectual skill.
Exactly. And our guide for this journey is Roger Salyu's article, Piagetian Controversies, Cognitive Competence and Assumptions About Human Communication. Think of this as your quick route to grasping these different viewpoints. Our mission today is to unpack these ideas about counting and what they tell us about learning in general, especially the crucial role of context and how we communicate. It's not just reciting 1, 2, 3, it's about understanding how we acquire any mental tool.
Right. And to get us started, you mentioned Piaget. It's helpful to remember that a common path in science involves building upon and refining major theories. Piaget's work is a classic example, suggesting that children develop through distinct stages of cognitive understanding.
Those famous stages, yeah.
But, as Celio points out, the really valuable moments often come when these big theories are challenged. It forces us to look at the underlying assumptions we might not even be aware we're making.
Okay, let's unpack this challenge then with the debate between Gelman and Siegler. Now, we're going to simplify a bit here for clarity.
Sure.
Siegler's perspective, in essence, is that children develop broad skills by being exposed to lots of different areas. Through this exposure, they start to notice patterns and abstract general principles.
Kind of like finding the common thread.
Exactly. Which eventually leads to greater competence in specific areas like counting. Gelman, in the article, characterizes this view as leaning towards what she calls a rote learning position.
Right. And Gelman's view takes a different angle. Her observations suggest that even very young children seem to grasp the fundamental principles of counting quite early.
So they kind of get it innately.
Well, maybe not innately, but early on. However, the key thing is they don't always apply these principles consistently across different situations.
Ah, okay.
This led her to develop the idea of utilization competence.
Utilization competence.
Yeah, which is basically the ability to assess a particular situation and then effectively use their knowledge to meet the demands of that situation. So the key insight here is that knowing the rules isn't enough. Kids need to figure out when and how to apply them. It's the bridge between abstract knowledge and real-world tasks.
Okay, here's where it gets really interesting because Celio steps in and offers a broader critique. He argues that by focusing solely on these ideas of either like built-in abilities or knowledge specific just to counting,
Right, these narrow focuses.
we might be missing a bigger picture of how cognitive growth actually happens.
Selye's central point, and this is crucial for you to consider, is that all human activity, and this absolutely includes what happens in a research experiment, is embedded within a social and cultural context.
Everything happens somewhere, basically.
Exactly. He wants us to broaden our focus to understand the full range of resources people use, not just what's going on in someone's head, but also the practical tools, the social cues they pick up on, all the things they use when they're trying to solve problems.
So if I understand you correctly, he's not convinced that we can settle this debate about how kids learn to count just by doing more and more experiments in a lab. Like a perfectly clean experiment isn't possible.
Precisely. Celio argues that no matter how carefully you design an experiment, you can always interpret a child's actions in more than one way. You could say they're applying a pre-existing understanding, right?
Yeah, the principle first idea?
Or you could say they're using a skill they've picked up through experience. The practice makes perfect idea. It really comes down to how you define what a principle is in the first place and who gets to decide on that definition.
That makes sense. He mentions Gelman's concept of a preformed kernel of conceptual competence, this initial spark of understanding. And Cellius seems quite skeptical about trying to pinpoint exactly what this kernel is.
Yeah, he questions his value.
And whether searching for it really advances our understanding of how children develop.
That's right. He raises questions about what this preformed kernel actually is and how we can meaningfully study it in relation to development. Furthermore, Celliu highlights that even Gelman herself acknowledges that the fact that children show inconsistent counting abilities, well, that could be explained by both sides.
Oh, interesting.
Yeah, it fits both the idea that principles come first and the idea that they develop after experience. This really challenges the notion that there could be one single critical experiment that definitively proves one side right and the other wrong.
Right, no silver bullet experiment. And he even takes a closer look at some of the evidence that's been used in this debate, like that study by Breyers and Siegler,
Mhm.
the one where children could count correctly themselves before they could judge whether a puppet was counting correctly.
Yes, Celio uses this as a key example to illustrate his point about the importance of context. He suggests that asking a child to count a set of objects is a very different communicative situation
Totally different task, yeah.
than asking them to judge whether someone else, like a puppet, is counting correctly. This is especially true if there's any uncertainty from the child's perspective about what even counts as correct in that specific situation with the puppet. What are the rules of this game?
Okay, so it's not just about the raw ability to count. The whole situation matters. This brings us to Lav's idea of structuring resources, which Celio discusses. What exactly are these structuring resources, and how do experiments typically try to manage them?
Okay, so structuring resources in this context refer to all the tools, pieces of information, even subtle social cues that are available to someone in a particular situation.
Everything that helps them figure it out.
Exactly. And these resources help them understand and act within that situation. Experiments are specifically designed to control these resources as much as possible, to try and isolate the particular cognitive ability being tested.
Like trying to create a sterile environment.
Precisely. The goal is to create a pure environment, free from any outside influences that might skew the results.
But Celio argues that this very attempt to create a sterile environment can actually lead us to a misleading understanding of how learning happens in the real world, right? It's too artificial.
Absolutely. He points out that even seemingly insignificant things within an experiment, like the way the experimenter reacts to a child's answers, maybe a slight nod, or even just the tone of their voice, can become a powerful structuring resource.
Oh, wow. Even subtle stuff.
Yeah, it inadvertently influences the child. He mentions the example of Breyers and Siegler telling children that the puppet knows his numbers, but sometimes he does it wrong.
Yeah.
This very framing of the task provides crucial information to the child,
It sets expectations.
right? It shapes how they approach the situation and what they think they're supposed to be doing. Is it a test? A game? Do I need to catch the puppet's mistake?
So the way we even present the problem becomes a key part of how the child understands what's going on. And even when researchers are trying their best to create these pure tests of numerical ability, the child's own interpretation of the instructions, how they understand what's being asked of them,
And how they choose to apply their existing knowledge.
they're all deeply intertwined with the social and communicative context of the experiment itself. You can't strip it away.
Precisely. Celio talks about the dream of unveiling the structure in all its purity, this aspiration to study cognitive abilities in a vacuum, separate from the messiness of the real world.
The mind in a jar, kind of?
Sort of, yeah. He connects us to a very old philosophical idea called Cartesian dualism, which proposes a sharp separation between the mind and the physical world. This kind of thinking can lead to the view of cognition as an independent entity that we can study in complete isolation.
And Celio really questions this fundamental assumption that counting a set of objects is essentially the same activity regardless of where or why you're doing it.
Exactly. He challenges the notion that counting blocks in a laboratory setting is fundamentally the same as, say, counting out change at a store or dividing snacks among friends.
The purpose matters.
The purpose behind the counting and the surrounding context are so different, and those differences likely shape how the counting is performed and what's even considered important or correct in each situation.
This leads us to Celio's idea that this whole debate isn't just about whose theory is the most accurate, but also about the kinds of discourses we create around counting and learning. What does he mean by discourses in this context?
Okay, so discourses here refer to the shared ways of talking, thinking, and understanding a particular topic within a community, like researchers or educators. Celio argues that our current discourses about cognitive skills are heavily influenced by what the psychologist Rummett termed negative scholarly rationalism.
Negative scholarly rationalism sounds intense.
It basically means the tendency in academic settings to focus on what children and even adults lack in terms of formal abilities, especially when they're in artificial settings like experiments or standardized tests.
So focusing on the gaps, the errors.
Right. Instead of looking at what someone can do, the focus is often on what they can't do according to a specific, often narrow standard.
So, in essence, we tend to highlight their shortcomings in these very specific formal situations, while often ignoring the practical skills and knowledge they demonstrate in their everyday lives, like street smarts versus book smarts.
Precisely. Celio draws attention to the work of researchers like Caraher and Lave, who have shown how people effectively use mathematical reasoning in real-world situations, like buying and selling goods in street markets.
I remember hearing about that, like kids selling things who were amazing at mental math for transactions.
Exactly. They often employ strategies that wouldn't necessarily be considered correct or even recognizable in a formal school setting, but they work perfectly in context. These everyday competencies are frequently overlooked when we prioritize performance in highly controlled, decontextualized experiments.
And Celio is quite critical of this common research practice using very simplified tasks, like a child counting red and blue chips, to make broad generalizations about their overall intellectual competence.
He really is. He emphasizes that a child's own interpretation of what the task is about, their level of motivation, are they even interested, and whether they even share the same goals as the experimenter, all play a really significant role in the outcome.
Things that are hard to measure.
Very hard. And these crucial social and interactional aspects, which are so fundamental to how we understand and solve problems in the real world, are often just left out of our theoretical considerations. Instead of being seen as essential parts of the process, they're treated as noise or something to be controlled away, like experimental error.
To really illustrate this point about how our assumptions can shape our understanding, Selye brings up the Newman et al. Study involving what they call problem isomorphs.
Ah, yes, the isomorphs.
These are problems that might look very different on the surface, but actually have the exact same underlying logical structure. Tell us about that study.
Right. So this study involved teaching students how to solve a particular type of problem related to combinations, using examples involving television and movie celebrities. Kind of a fun context. The researchers then presented the students with a new problem that had the exact same underlying mathematical structure, but this time the scenario involved chemicals mixing.
Totally different topic.
Completely different context.
Mm.
What they discovered was that it was surprisingly difficult for the students to see the connection between the two problems. They struggled to apply what they had learned in the celebrity context to the chemical context.
Even though the math was identical.
Even though the abstract structure was identical, the students often interpreted the chemical problem in completely new ways, based on their own prior knowledge and assumptions about chemistry, rather than seeing the underlying logic they'd just learned.
Wow. It really highlights how challenging it can be to ensure that everyone understands a task in the precise way the researcher intends. You bring your own baggage to it.
You really do. And Selye makes this back to Gelman's underlying assumption, maybe an implicit one, that you can somehow design a task that bypasses these issues of interpretation and directly reveals a child's true counting ability, free from any contextual influences.
Like finding the pure essence of counting ability.
Exactly. Celio sees this assumption as part of a broader set of beliefs about communication and learning. Beliefs that not only influence how we design our experiments, but also how we evaluate learning and performance in various other settings, notably in schools.
He even shares a really thought-provoking anecdote about a math problem framed in two different ways. One involving cows and milk, and the other involving school lessons per week.
Yes, this is a fantastic example from Celio's own work with Wyndham. A seemingly straightforward problem about calculating the total number of lessons a student has in a week, something directly related to their daily life, you'd think.
Should be easy, right?
You'd think. But it turned out to be much more difficult for children than a problem with the exact same mathematical structure, but framed around calculating the amount of milk a cow produces in a week.
That's counterintuitive. Why?
Well, what was particularly revealing were the negative reactions from teachers. They felt the lessons per week problem was somehow unfair to include in a math exercise.
Unfair? How?
Because it introduced real-world complexities beyond just the pure calculation. Things like the fact that a week might not always have the same number of school days due to holidays or half-days or other events. The kids were bringing in that real-world knowledge.
So the messiness of reality interfered with the clean math problem.
Precisely. It really underscores this tendency within formal education to favor these decontextualized problems where real-world meaning and context are deliberately stripped away, supposedly to test pure arithmetic skills.
Get rid of the complications.
And Celio argues that while this approach might aim for a certain kind of precision, it can also have the unintended consequence of alienating people from truly understanding the actual meaning and purpose of what they're doing with numbers. The underlying assumptions about what counts as proper or valid knowledge in an experimental setting often mirror the expectations placed on children in more significant social settings like the classroom.
So, given all this critique, where does Selye suggest that research in this area should head? He proposes a shift in focus, right, towards understanding the cultural practices surrounding counting.
Exactly. He advocates for us to start looking at how people learn to participate in the everyday activities where counting and quantification are actually used in the real world, across all sorts of different social contexts at home, at play, at work.
Not just in the lab or the classroom.
Right. He believes this approach could help us move away from this somewhat elusive quest for abstract, context-free structures of counting ability, this kernel idea.
And by observing these real-world practices, we might gain a much richer and more nuanced understanding of how children actually use numbers in their daily lives, and also how they learn to share their perspectives and understandings in these activities, how they learn to communicate about numbers.
Celio even suggests that if we take a close look at how counting naturally occurs in the world, we might be surprised to find that the solitary act of one person counting isolated objects, like those chips in the experiments, which forms the basis of so many of our scientific studies,
The standard experimental setup.
is actually a relatively rare social situation in the grand scheme of things. It's not how counting usually happens.
That's a really thought-provoking point. And he sees a potential for positive change in this kind of research, a kind of emancipatory force, he calls it.
Yeah, what does he mean by that?
By making visible the often unspoken assumptions that are embedded in how we teach and assess counting in schools. This could highlight how these formal approaches might not always align with perfectly reasonable and effective ways of using numbers in other, more practical settings, like the street vendor kids.
Right, it might show a disconnect. It could challenge the idea that the school way is the only right way, or even the most useful way in many situations. He references work by Walkerdine and Edwards here, too.
So it's about questioning the established norms.
Ultimately, yes. Salesio argues that understanding these different perspectives on something as seemingly simple as learning to count is deeply connected to much broader issues. Issues of communication, ideology, and even the distribution of power in how we define and value intellectual competence in our society. Who decides what counts as smart?
So to bring this deep dive to a close, the key takeaway for you listening is that the development of even a seemingly basic skill like counting isn't just about innate talent or repeated practice in isolation. It's deeply intertwined with the social context in which it happens,
Where you are, who you're with.
the way we communicate about it, and how individuals interpret the situations they find themselves in. Understanding these different viewpoints on counting competence really offers us valuable insights into the whole process of learning and mastering intellectual tools in general, not just numbers.
Yeah, it's a much bigger picture. And this raises a really important question for you to consider. Think about the everyday situations in your own life or in the lives of people you know where numbers are used, maybe cooking, budgeting, sports stats.
Right, anywhere.
How does the specific context of that situation actually shape how the counting or calculation is done and what's considered to be correct?
Yeah.
Are you estimating? Do you need precision?
What are some of the unspoken assumptions that are at play in those moments?
Consider how this more contextual view might change how we approach learning and education, not just for children learning to count, but for ourselves as well, anytime we're learning something new. Does the context help or hinder?
A lot to think about there. Thanks so much for diving deep with us today.
Yeah, great discussion.
Until our next exploration.